Hello, everyone. Welcome to this course on installation and commissioning of electromechanical equipment. I am Chui Ming Jun. Today we will study Chapter 3, PLC Program Controlled Punching on the Training Bench Ladder Diagram Design, Part 1 Basic Control and Initialization. Ladder diagrams are a very important type of graphical programming language in PLC programming. They offer a clear visual representation, are easy to understand, and effectively convey control logic. Next, I will guide you step by step through the design of ladder diagrams. We will explore this topic from the following parts. 1. Initialization. Let's begin with Program Segment 1. Initialization and power-on preparation. After the system is powered on, the main program and subprograms are always enabled, and subprograms are called and executed. 2. AC motor start and stop control. Next, we'll look at Program Segment 2 and Segments 3, 4, 6, which together control the start and stop of the AC motor. AC motor start. In Program Segment 2, when the start button is pressed and all the following conditions are met, the manual and automatic mode selector switch I0.6 is set to 1, automatic mode. The AC motor is at the home position, I1.5. The stepper motor is at the home position, I1.6. The X-axis servo motor is at the home position, I1.4. And the Y-axis servo motor is at the home position, I1.1. Then the AC motor will start rotating forward at medium speed. At this point, the start flag M0.0 is set to 1, and the subprogram reset flag M0.5 is cleared to 0, indicating the subprogram is reset. This is like shifting the car into gear and stepping on the accelerator to start driving. AC motor stop. Program Segments 3 to 4 describe two ways to stop the AC motor. The first way is to press the stop button, M10.1, on the HMI, where the intermediate memory M0.1 is set to 1. The start memory M0.0 is cleared to 0, and the reset memory M0.2 is cleared to 0. The second way is to press the reset button, M10.2, on the HMI or turn the manual and automatic mode selector switch XK1 to automatic mode, I0.6 equals 1, which sets the reset memory M0.2 to 1 and clears the start memory M0.0 to 0. This is like pressing the brake pedal to bring a car to a stop. AC motor stop in manual mode. Program Segments 5 to 6 emphasize that in manual mode, the reset memory M0.2 is cleared to 0, the forward and reverse control signals for the AC motor are both 0, and the AC motor stops running. Even in manual mode, we can stop the AC motor easily, ensuring both flexibility and safety in control. 3. Start button and pause button control. Program Segment 7 involves control of the start button, I0.4, and pause button, I0.3. When the start button, M10.0, on the HMI is pressed, the intermediate memory M0.0 is set to 1. Pressing the pause button SB1, I0.3, on the panel stops the AC motor, and sets the intermediate memory M0.4 to 1 at the same time. When M0.4 is set to 1 and the start button SB2, I0.4, is pressed, a rising edge trigger causes the AC motor to start rotating forward at medium speed, and M0.4 is then reset to 0. 4. Reset triggered reverse rotation and low speed homing of AC motor. Program Segment 8 explains how the AC motor reverses and returns to its home position at low speed when a reset is triggered. When M0.2 equals 1 or M8.0 equals 1, the automatic mode is enabled, I0.6 equals 1. The Y-axis is at its home position, I1.1 equals 1. And the system has not yet reached the motor home position, normally closed I1.5 equals 1. The AC motor rotates reversely at low speed. The electromagnetic clutch is triggered, Q1.1 equals 1. Engages with the shaft, and the brake is released, Q1.2 equals 0, allowing the punching mechanism to rotate. Once the home position is reached, I1.5 equals 1. The reverse motion stops. The clutch disengages, Q1.1 equals 0. And the brake is activated, Q1.2 equals 1, to lock the shaft. The punching mechanism then disengages and stays at the home position. 5. Home button control. Program segments 9 to 10 describe how the home button, I0.5, triggers the X-axis and Y-axis homing actions. Pressing the home button, I0.5, triggers counter C1 to count. When C1 equals 1, the home position solenoid is energized. Value equals 1. When the start button, I0.4, is pressed, or when C1 equals 2, counter C1 is reset. 6. Control of the material clamp solenoid and intermediate relay. Program segment 11 defines the routine for activating the material clamp solenoid and setting the intermediate relay M5.0 to 1. 5 conditions must be met. The AC motor is rotating forward, Q0.4 equals 1. The start button SB2 is pressed, I0.4 equals 1. The cross-table object sensor, I1.7, detects material, a photoelectric sensor. A signal is reflected back when material is present. The X-axis servo motor is at the home position, I1.4 equals 1, and the Y-axis servo motor is at the home position, I1.1 equals 1. When these conditions are met on a rising edge, the intermediate relay M5.0 is set to 1, triggering the clamp to secure the material. 7. SHRB shift command and punching process. Program segment 12 explains the use of the SHRB shift command to sequentially shift the bit set in M5.0 through M5.1 to M8.0, executing the 25-step punching process. From initial trigger to punching completion, each step is governed by clear conditions and actions. The shift command enables automatic control of the entire punching process. This is like a precise production line completing each task step by step according to a preset sequence. 8. Punching completion and motor stop. According to program segment 13, when the cylinder retracts, M7.7 equals 1. Upon completing the punching, the AC motor forward rotation and medium speed flags are set to 0, stopping the motor. Alternatively, pressing the stop button also brings the motor to a stop. This marks the end of the punching operation, and the system returns to its initial state, ready for the next work command. 9. Summary. In this lesson, we have learned how to design the ladder diagram for the PLC program control punching on the training bench. Designing the ladder diagram requires careful analysis of the control logic and the proper setting of conditions and actions to ensure stable system operation. In practical applications, we must continue to practice and refine our approach to improve our programming skills. I hope you will practice more after class and become proficient in ladder diagram design techniques. Lastly, please complete the exercises after class. That's all for this lesson. Thank you for your attention. See you in the next class.